Good morning, good afternoon, good evening, ladies and gentlemen, and today we're going to be talking about trigonometric ratios for angles greater than 90 degrees. Okay, so before we even go into this actual lesson, we need to be able to understand the terminology behind everything. So we're starting off here with a word wall. So we're going to relate this to everything that it has to do with. Okay, so before you can understand what any of these things are, you have to understand first and foremost, what is a ray? Well, the ray is basically any sides that belong to the angle. So when I say any sides that belong to an angle, so you see this angle here, what are the two sides that make this angle? Because obviously every single side, every angle can only be made between two things. So these would be the two sides here, this would be the two sides here. So over here, you have one ray here, one ray here. These two rays, which are the sides, are the ones that are responsible for making this angle. Okay? So of course, this belongs over here. Next up, now that you understand what the rays are, you need to look at what standard position is. So basically, an angle is in standard position if the vertex is located at the origin. So first and foremost, what is the vertex? Well, the vertex is the point where they both congregate. This is the vertex between these two lines. These two lines join up right here. And right there happens to be where the origin is. It's where my big origin is. Oops, wrong color there. Let's go with red. It's where my origin is. So since my origin happens to be in the same spot of the vertex that's made from these two lines, I could say that it is in standard position. Next up, we have the initial arm. The initial arm is the ray that is connected on the positive x-axis. So, where is the positive x-axis? Well, x is not positive here. This is where all the negative x's are. Remember, this is like a number line, so this would be -1, -2, -3, -4. So over here, I'd have +1, +2, +3, +4. So all the values here for my x are positive. So the line that was made in this corner is what we would call the initial arm. So we call this the initial arm because it is the line that was made in the positive x-axis. Positive. Next up, the terminal arm is the other ray that rotates around the origin. So basically, if this is my angle, the angle goes all the way around, and if this is where my angle is supposed to be, and that's where the line is made up, we call that the terminal arm. Now, the terminal arm is basically the measure of the angle from the rotation that starts at the terminal arm all the way to the terminal arm. Okay? So that angle is made from that rotation. Now you can see it's going counterclockwise here. Okay? So remember, the terminal arm is always the ray that's made after you do your rotation. So if I rotate it up to here and a line, that would be the terminal arm. So if I rotate up to here, that's terminal arm, that's a terminal arm, that's a terminal arm. Okay. All right, so a related acute angle is the angle between the terminal arm of an angle in the standard position in the x-axis when the terminal arm lies on any other quadrant than the first one. So basically, if I had my terminal arm anywhere here, I would not have a related acute angle. But when your arm happens to go in any other quadrant, so here or here or here, you would have what they call as the related acute angle, which is basically the angle between your line and the x-axis of that quadrant. Okay? And finally, we look at the principal angle, and I talked about this earlier. The principal angle happens to be when you're measuring from the initial arm all the way till your terminal arm in counterclockwise fashion. And that will get you what your principal angle is. Now, if you wanted to determine the value of the angle using the coordinate grid, because obviously if you're using this as an x and a y, so this is my y, that's my x. If I want to try to find out what the angle is using that, the terminal arm would be a point xy. Obviously, if I put my terminal arm here, let's say I had a point, well, that would have to be a xy point. Okay? Okay, so the side that's opposite of theta we can call is y. Because what's opposite of theta? Well, that's the y. Look directly across, you get y. And what's adjacent? Well, adjacent, which is right beside it, is my x. So that's my opposite. That's my adjacent. Okay? The hypotenuse, which is the last thing we need here, which you can call r, can be found using the Pythagorean theorem. So you can find r using Pythagorean theorem, which is your hypotenuse. Okay? So let's look at how we would accomplish this in some examples, okay? Okay, so let's take a look at this example here. So let's say this is my terminal arm here. So this is my terminal arm. This would obviously be my initial arm because it's my x. So this is the angle made between them. We would call that the principal angle. So if I wanted to figure out what my r is, I'd have to complete this triangle by drawing a line that goes straight down. Okay. Now, when I complete this, I know that right about here, when these two lines meet, this is obviously a point at xy. Now, what do you suppose this one is here? Well, from here to here, this would be a y value here. So we're just calling that y because we already talked about it on the other page. This is going to be y. Okay, so we have theta, we have x, we have r. So if I'm trying to solve for this, well, I know that my r, so if I'm doing Pythagorean theorem, which, just a reminder, a squared plus b squared is equal to c squared. My r is my hypotenuse. So in this case, I'm going to end up having x squared plus y squared is equal to r squared. So if I want to solve for r, well, r should just be, take the square root of them, r is equal to the square root of x squared plus y squared. Okay? Now, some other things we do know about this. Let's say I wanted to take sine or cosine or anything like that. Well, I know that sine of theta, so sine of theta, well, that should be opposite over hypotenuse. So opposite over hypotenuse. So opposite, which is y, over r. And cosine of theta should be, well, adjacent over hypotenuse. So adjacent over hypotenuse. Okay. So using all that together, that should in general find you any of your terms. For sine, for cosine, you can guess how the tangent would go from there. and this should work every single time. So what you notice here is that your r, your hypotenuse, is always going to be your two sides added together squared. Okay, so let's see how this works in some examples. Okay, so let's get into this question here. So we have here the point 610. So obviously this is my x, that's my y, that's my x, that's my y, is on the terminal arm. So terminal, keyword there, terminal arm of an angle theta in standard position, which means I know that the angle is on my origin. Find sine of theta and cos of theta. Okay? Now, there's two different ways you can do this. The first way is you can, so step one, so method one. So your first method would be to graph it. Okay, now obviously some people don't prefer this, but let's take a look at it anyways. So if I graph this, well, I know that 610 is my terminal arm, which means 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So my point would be right here. So I know that's my terminal arm. Now it's just a matter of connecting it. Obviously, you should be using a ruler, and this should be straight. So that's my terminal arm, which means my angle would be from here. It's theta. I know it's there because it's a standard position, which means it has to happen from the origin. Okay? Once I do that, well, then I'm just going to complete this triangle here. I know that it's only as high as my y, and my y was 10. I know my x was 6. So I need to find out what this is. So to do that, Pythagorean theorem. From the before, I know r is supposed to be the square root of x squared plus y squared. So basically, 6 squared plus 10 squared. So that should be the square root of 136, which is equal to, so there's two different ways you can show what it's equal to here. You can either show it through radicals or you should show it through decimals, but in this unit, every single time, I do always want to get the exact answer, unless the question says otherwise. So exact meaning I don't want decimals. So I should notice here, if you guys remember from our radical unit, that I can split this up. I can split up 136. I can split that up into what? Square root of 4 times square root of 34. Because 4 times 34 will give me 136. If you're having trouble remembering that, please ask during the Zoom session. We can go over prime factorization again, which should give me 2 root 34. Okay? So that's the first method. I found my r there. And then, of course, now to find your sine and cosine, well, we have all of our stuff now, so you could just go straight into that by going opposite over hypotenuse. So sine of theta should be 10 over 2 root 34. Obviously, I cannot have a root on the bottom, so I would need to multiply the top and the bottom by root 34. I can also do 10 divided by 2, which will give me 5. So I'll be left over with 5 root 34 over 34 times 34, and then you take the square root of that, it's going to give you 34. Opposite over hypotenuse. Okay? Please try out cosine yourselves. Pause the video for a sec. Okay, I'm assuming you guys are back now. So cosine theta adjacent over hypotenuse. So adjacent would have been 6. Hypotenuse is still going to be 2 root 34. Same thing as before. Which is going to give me Again, my 2 can actually cancel out here with my 3. So 3 root 34 over 34. Okay? So that's how you find the sine and cosine using the first method. Second method is quite smaller. Second method is just basically skipping to this step right here, because we learned before r should be this. So we're going to use our identity. So basically the second method is skipping the hard work and going right to the identity. Use the identity. Which means you're going to go straight into this. R is equal to square root of 6 squared plus 10 squared is equal to square root of 136. And you're going to get the same thing as you got here. Okay, so that's the 2 different ways you can do that. Okay, so we're going to end off this part of the lesson with some examples in relationship to what you just saw before. Okay, so I want you guys to try this. I want you to pause and try it yourself before you unpause and see what the answers are. Okay, so I'm assuming you guys have paused and you're back, so I'm going to split this up. So, we want to do this type of questions. We're going to be using this opportunity to write down our steps here. So, I'm going to actually separate this here and put my steps here. So, steps. So, number 1, and I'm assuming most people are going to be using method 2 because it's less involved. So, step 1, use r is equal to x squared plus y squared to find r. Okay, and then 2, we're going to use the other identities we learned, which we made with SOHCAHTOA, but that sine of theta was y over r. Cos of theta was x over r. Okay, so let's go into that. So using it, you know r is going to be equal to the square root of 5 squared plus 3 squared, which is equal to the square root of 34. 34 is as small as I can go there, so that's my r. So let's go into our sine. So sine should be y over r. So my y was 3, my r is root 34. I don't like having a radical on the bottom, so I multiply the top and bottom by that root, which gives me 3 root 34 over 34. Okay. Cosine, same thing. Which, once again, you're going to have to multiply the top and bottom, so you're going to get 5 root 34 over 34. Let's do b. For b, once again, you're going to have r square root, 2 squared, which is 4, 7 squared, which is 49. So you're going to have r is equal to the square root of 53. 53 is literally the smallest it can go, so we're leaving it like that. So once again, you go sine of theta, and I'm going to do these 2 steps at 1 here. So I know that should have 7 divided by square root of 53, so I know I'm going to end up having that 53 on the top, and I know on the bottom I should have the number 53. Just doing multiple steps in one there. And finally, 2 root 53 over 53. Same thing here. Let's do this. So r should be 1 squared, which is 1, plus 6 squared, which is 36. Square root of 37. 37 is the smallest I can go, so sine of theta. My y is 6. I know I'm going to end up having that at the end after doing my multiplication. And finally this. And that's all for this part of the lesson. So we stuck to angles that were in the first quadrant for this lesson. So in the next part, in part 2, we're going to be looking at angles that are greater than 90 degrees and what we're going to do with them. Okay, have a great day.